I'm University of Illinois Extension's Todd Gleason. You know, the nation's hog herd has been under attack by a deadly virus for more than a year. PEDv quickly kills baby pigs. It's had a dramatic impact on the number of hogs raised in the United States. Now, those who grew up on the farm probably would have called it a really, really bad case of the scours, but it's far worse. Earlier this week, I asked University of Illinois veterinarian Jim Lowe to teach us about the PED virus.
So let's talk a little bit about PED at kind of the base level. So PED is porcine epidemic diarrhea virus. It's caused by a coronavirus, and so you've heard other coronaviruses in the news. So the MERS virus or the Middle Eastern virus, the SARS virus. There are a lot of other coronaviruses that infect people. There are coronaviruses and other coronaviruses that infect pigs. We call that transmissible gastroenteritis. And there's coronaviruses that infect basically every species. Cows get coronavirus, sheep get coronavirus, dogs get coronavirus. So coronaviruses are very common viruses. This particular virus, like the TGE or the transmissible gastroenteritis virus, affects part of the small intestine. So the small intestine has a bunch of little fingers in it. Those fingers are responsible for absorbing nutrients. This virus infects the cells around or that line those fingers, and those cells die, which means that the pig can't absorb nutrients anymore. So the diarrhea is actually because they can't absorb what they take in, and so it passes straight through without being digested and absorbed. It means they also can't absorb water, and they actually suffer from dehydration more than they suffer from actually malnutrition. So what's interesting about most of these viruses and most diarrhea viruses, and so the most common killer of human infants is actually rotavirus in third world countries, and so viruses are very, very common. PED affects baby pigs, so neonatal pigs, and particularly those pigs under a week of age. And we don't know why. Part of it is the theory is right, they're just more susceptible, they don't have as many reserves, but they may also be just, actually the virus may be more effective in growing in them. But pigs in less than a week of age have really severe damage to their intestine. Hence, they can't resorb nutrients. More importantly, they can't resorb water. And basically, for pigs less than a week of age, the virus is effectively 100% fatal.
What do we know about its transmission?
So we always think about how does viruses move, how do disease move. In this case, it's what we would refer to as oral fecal. So contaminated manure, fecal material, is the primary route of transmission. So anything that could have manure on it can basically have PED on it. So any way anything coming out of another farm can move. So we've done a study and documented that trucks are really a big way that we can transmit disease. We published that data in EID. Emerging infectious diseases, really from the beginning of the outbreak, that it appears that animals, live haul trucks moving pigs between farms are a big risk. We know that many other things can be contaminated. There's been work done that it'll survive in manure for weeks. One of the original studies was it was there for 3 weeks, and that's because they quit testing it 3 weeks. The study was designed to go 3 weeks, and they could still find virus at 3 weeks. There's certainly been some suggestions that feed contaminated with manure can be a problem. There's some evidence, fairly strong evidence of that, if we get some cross-contamination with manure and feed, that it moves that way. Supplies moving in and out, if a boar stud or a source of the semen gets infected with PED, it can be on the outside of the bottles. So it's not in the semen itself, but there's so much virus that it's on the outside of the bottles and it moves around. One thing that's exceptionally interesting about this, so compared to TGE, a gram or a milliliter of cc, so just a little bit of virus, contains about 1 million infectious doses of PED. So I can infect 1 million pigs with a gram of feces. And so even things that appear to not be contaminated, not have fecal material on them, can still have enough virus on it to infect another pig. So the stuff moves around very, very easily. It survives very well in the cold and without sunlight. And so you know, this virus was introduced last April. We had some outbreaks relatively there in May and June. But by July it had kind of quieted down, and then when it got cold again in October, November, December, it started to ramp back up, as you exactly would expect with the coronavirus. So we got back in. It's been better here. Here we are the 1st of June basically, and it's gotten better, but you know, nothing like sunlight and a little warmth to get rid of.
Do we know how it developed and where it came from?
So we know the virus is genetically similar, very, very genetically similar to a virus that was in China. So the original PED was identified in Europe. That's a genetically distinct virus. That was in the 70s. It's basically gone from Europe today. And there's a variant circulating in China today. In fact, all over, there's PED all over in Asia. But there's a variant from China that was placed in GenBank, which is the repository of genetic information about viruses, and the U.S. virus matches up within about 0.5% or something. So we're confident the virus came from China. We have no idea how it got here.
How much damage has it done?
Well, if you look at the USDA numbers, there's some projections that we're going to be down about 10% of the pigs. Those numbers probably haven't fully panned out. In that we've had more pigs coming to market than that, so it's really hard to get a full estimate on where we're at. Individual farms that are affected basically are going to lose at least 4 weeks of baby pigs. So if they're having pigs born every week, basically there are 4 weeks of pigs that they're going to lose, and there's nothing we can do to stem the tide. If we do some intentional exposure, get the herd infected very quickly, we can keep that loss in the individual herd to about 4 weeks, 5 or 6 on the worst end of that. So that's just 10% of the production for the year in that farm. If we farrow 52 weeks a year and you lose 5 weeks of pigs, it's plus or minus 10%. And so it's a significant hit to the farm. It's a lot of money. Particularly, pigs have been really, really valuable here the last year, partially because of PED.
Can a herd over time become tolerant?
Yeah, so the herd develops immunity. It's not great immunity. But they do develop immunity, and the baby pigs will quit dying. So mom builds an immune response. Mom secretes that antibody in those cells in her milk, in her colostrum primarily, and then also IgA in her milk. And so the pigs that are born about 2 weeks after the initial outbreak survive at a fairly normal rate. Those pigs, even post-weaning, will do fine when they go to market. So it's how quickly you can make sure every mom gets exposed. The adults are not particularly affected. They have a little mild diarrhea, much like viruses in people. No big deal in humans. You feel bad for a couple of days and you get over it. So the adults are not affected. And so how do we get mom infected so mom can build an immune response, and then mom can produce enough antibodies so that those piglets aren't infected?
Does that mean it will run its course in the U.S. herd at some point?
Well, we would like to think that. However, unfortunately, it does not appear that the immunity is particularly long-lasting. So it appears that within 4 to 6 months after the initial infection, immunity in the herd starts to wane, and these herds appear to be susceptible again. So we don't think, if you look at some estimates that are out there, we don't believe that the outbreaks next fall will be as bad as they were this fall, maybe half as bad or a quarter as bad. So 2.5 to 5% of the pigs, if you believe the 10% estimate this year. But this is a disease that's here to stay, and it'll get better over time, but it's not going to go away.
How much work is being done to develop a vaccination?
Yeah, so there's a lot of work going on in vaccines, and so I think what's important to remember is that a year ago we had no diagnostic capability. We couldn't even diagnose the disease in the U.S., and so within about 45 days we had really quite good diagnostic capabilities. They continue to improve those. Vaccine research started fairly quickly. One of the challenges is you can't grow this virus very easily in cell culture, which is how we grow viruses. So we've had to learn how to grow the virus, and there's a lot of work being done on that. They still haven't perfected that at a commercial scale. There are some biotech vaccines being made. So we're making a vectored vaccine where you insert part of the PED gene into another virus, grow that up to produce the protein. That's being done. It appears that some of those vaccines are of a limited benefit in animals that have already been exposed, but we cannot produce a very good immune response in animals that have never seen the virus before. So yes, we would hope that we could have a vaccine, but if you look at our track record for coronavirus vaccines in general across all the species, it's pretty poor.
What's your involvement and the University of Illinois' involvement?
Yeah, so my involvement is obviously my clinical practice. It's been, shall we say, the hot topic the last year in terms of devising management plans and control strategies. And how do we do that? So I've personally been involved from a clinical standpoint very much on the front lines of trying to help people through this, producers through this. U of I's involvement has been, we were heavily involved in this transport study. So that was a U of I project we did on the transport study initially. There's some other work being done on some basic viral mechanism stuff and how does it induce immunity out of the College of Veterinary Medicine. Don Wan Yu is working on that stuff today. And our group today continues to look at some transmission methods and what's happening with transmission. How do we sample it better to understand transmission? So there's active research going on campus today to try to move the ball forward. And again, we're starting at ground zero, so it seems like we're still working on basic stuff, but it's really been impressive what, as a research community, we've been able to accomplish in the last year.
That's University of Illinois veterinarian Jim Lowe discussing the PED virus in the U.S. hog herd. I'm University of Illinois Extension's Todd Gleason.